Imagine a world so extreme that a single year is shorter than a single day on Earth. This might sound like pure science fiction, but astronomers have already discovered such a planet orbiting far beyond our solar system. This world challenges our understanding of time, distance, and the very definition of a year. From the moment scientists confirmed its existence, curiosity has grown rapidly across the scientific community. After all, how could a planet complete its entire orbit in less than 18 hours? The idea of a year lasting only 18 hours sparks countless questions. How close must this planet be to its star to orbit so quickly? Could such a world ever sustain life, or is it simply too extreme? These mysteries fuel our desire to dig deeper. Unlike Earth, where the rhythm of days and years provides balance, this planet exists in a constant race against time. In this video, we'll uncover everything that makes it one of the most extraordinary discoveries in astronomy. Curiosity has always driven humanity to look up at the sky and ask, what lies beyond? But every so often, the universe gives us answers that seem stranger than imagination itself. This planet's unusual orbit forces us to rethink how diverse worlds can truly be. It's not just about its speed, but also about what this speed reveals regarding the universe's possibilities. Could there be countless other planets with bizarre orbits waiting to be found? Our journey begins with a simple but powerful fact. The universe is full of surprises. Scientists once believed that solar systems always followed patterns like ours. But the discovery of this planet shows that the cosmos often defies expectations. And while Earth feels stable with its 365-day orbit, this other world lives in a constant sprint. That stark contrast makes it irresistible to study. Imagine waking up on this planet. You go to bed at night, and by the time you wake up, an entire year has already passed. Seasons wouldn't exist in the way we know them. Instead, life, if it could survive, would need to adapt to an unbelievably fast cycle. The rhythm of existence here would be almost unimaginable, and that's just the beginning of its mysteries. This planet doesn't just challenge scientific theories, it challenges imagination itself. When we talk about a year lasting less than a day, we are essentially rewriting what we think we know about time. The very concept of time becomes flexible and strange in these conditions. What feels natural to us on Earth is just one version of what time can look like in the universe. Every discovery like this forces us to look inward as much as outward. Why do we consider 365 days normal? Only because that's what Earth gave us. But as this planet shows, normal is just a local rule, not a universal one. This realization opens new doors in philosophy as much as in science. If time is so relative, what else about life and existence might be equally fluid? Astronomers were astonished when they confirmed the measurements. An orbit of only 18 hours seemed too extreme to be real. But through advanced technology and patient observation, the data could not be denied. It was there, circling its star at breathtaking speed, proving that nature often creates rules we never expected. The discovery marked a milestone in exoplanet research. Of course, every discovery comes with more questions than answers. What is this planet's surface like? What is it made of? Could we ever send a probe to study it up close? Or will it remain forever a mystery we can only glimpse from a distance? These questions inspire missions and keep curiosity alive. And so, with the mystery set before us, let's dive deeper. To understand the strangeness of this planet, we must first break down what a year lasting 18 hours really means. Once we uncover the science behind this phenomenon, the mystery becomes even more fascinating. What does a year lasts 18 hours mean? When we talk about a year, we usually think of Earth, 365 days, one trip around the sun. But in astronomy, a year is simply the time it takes for a planet to complete one orbit around its star. For Earth, that means moving 150 million kilometers in a nearly circular path around the sun. For this planet, however, the path is far smaller and the speed is far greater, allowing it to complete its orbit in less than a single Earth day. This means that the concept of time is not fixed. It changes depending on where you are in the universe. A year on Mercury, for example, lasts only 88 days. That already seems fast compared to Earth. But when you realize this new planet manages to complete its orbit in just 18 hours, Mercury suddenly looks slow by comparison. Such speed highlights how diverse planetary systems can be. The reason behind this extreme orbit is simple but fascinating. Distance. This planet orbits extremely close to its parent star. The closer a planet is to its star, the stronger the gravitational pull, and the faster it must move to stay in orbit. This balance between gravity and speed is what defines orbital periods. In this case, the balance leads to an orbit shorter than one Earth day. To put this into perspective, imagine Earth suddenly moving as close to the Sun as this planet is to its star. The heat would instantly destroy life, and our orbit would shorten dramatically. But because Earth is at a sweet spot distance, life thrives. This comparison helps us appreciate how rare and fragile the conditions on our planet really are. Understanding orbital periods also explains why astronomers were so amazed at this discovery. It's not just about numbers, it's about extremes. Nature doesn't play it safe. Instead, it creates worlds that stretch our imagination. From scorching hot giants to icy exoplanets, each discovery reminds us that the universe is far more creative than we ever expected. Another important point is how scientists measure these periods. They often use the transit method, observing dips in a star's brightness when a planet passes in front of it. By recording these dips, astronomers can calculate how fast the planet is orbiting. For this particular world, the dips showed a rhythm so rapid that it stunned researchers. In human terms, the idea of living with a year so short is mind-blowing. Birthdays would come every 18 hours. A single week, as we understand it, would equal hundreds of years on this planet. Such exaggerations might sound funny, but they emphasize just how bizarre time becomes outside our earthly frame of reference. When thinking about such a fast orbit, another question arises. Does the planet spin on its axis, and how long is its day? In some cases, planets close to stars become tidally locked, always showing the same face to the star. If that's true here, then not only is the year extreme, but the day could be even stranger. That would make life even more unimaginable. The orbit of 18 hours also has consequences for the planet's environment. The intense gravitational pull and the star's constant radiation likely make it hostile. Any atmosphere would be unstable, boiling away under extreme heat. For humans, stepping onto such a world would be impossible without futuristic technology. In summary, when we say a year lasts 18 hours, we're not exaggerating. We're highlighting how flexible and strange time truly is across the universe. This single fact transforms the way we think about planets and their diversity. And with that foundation set, it's time to explore how this incredible world was discovered. Discovery of the planet. The discovery of this planet was not accidental. It came from years of dedicated observation by astronomers searching for worlds beyond our solar system. Using space telescopes, scientists constantly scan the sky for subtle signs that reveal hidden planets. One of the main methods involves detecting tiny changes in a star's brightness. Whenever a planet passes in front of its star, the light slightly dims, creating a pattern that can be analyzed. It was through this method that the astonishing 18-hour-year planet was identified. The telescope that played a major role in this discovery is part of humanity's most ambitious space missions. Its highly sensitive instruments are capable of detecting variations in starlight smaller than a fraction of a percent. Without this level of precision, such a planet might have remained invisible. By carefully recording repeated patterns, astronomers noticed the unusual rhythm, dips in brightness occurring far more often than expected. That rhythm revealed the planet's incredibly short orbit. Confirming the existence of the planet required time and consistency. Scientists had to make sure the dips were not caused by noise, technical glitches, or other cosmic phenomena. After months of gathering data, the results were undeniable. This was a real world, orbiting its star in just 18 hours. The discovery was announced, and it immediately captured global attention. Such an extreme planet could teach us much about the diversity of the universe. What makes the discovery so fascinating is that it challenges our assumptions. For centuries, humans believed that planets should follow orbits similar to Earth's or the other planets in our solar system. But finding worlds like this proves that our system is only one example of countless possibilities. This discovery reshaped astronomy, showing that the universe doesn't follow a single model when creating planets. The announcement of the planet's discovery also created excitement outside the scientific community. News outlets, documentaries, and space enthusiasts quickly shared the story, fascinated by the idea of such a strange world. The phrase, "a year lasts only 18 hours," became a captivating headline, sparking curiosity worldwide. People who had never cared about astronomy before suddenly wanted to know more. For scientists, the discovery opened new opportunities. By studying this planet, they could test theories about planetary formation and orbital mechanics under extreme conditions. It became a case study in how gravity and heat shape celestial bodies. Every measurement taken provided a new clue about the balance between stability and destruction in planetary systems. Interestingly, the planet wasn't alone in reshaping theories. Other exoplanets had already shown bizarre properties, such as orbiting two stars or raining molten glass. But this 18-hour orbit stood out as one of the most extreme examples yet. It confirmed that the universe is more creative than we can imagine, constantly presenting surprises that push science forward. The discovery also showed the importance of collaboration. Hundreds of scientists across the globe worked together, analyzing the same data and debating interpretations. Astronomy is rarely the work of a single person. It is the result of global cooperation. This teamwork strengthens confidence in the findings, ensuring that such discoveries are reliable. Beyond the technical achievement, the emotional impact was profound. For many astronomers, moments like this justify years of dedication. To uncover something so unique and share it with the world is deeply rewarding. It proves that human curiosity has no limits, and that even in the vast silence of space, we are capable of finding extraordinary stories. Thus, the discovery of the 18-hour orbit planet is more than just a scientific achievement. It is a testament to human perseverance and imagination. It reminds us that every star in the night sky could hide secrets waiting to be uncovered. And now that we know this planet exists, the next step is to locate it precisely within the universe. Location in the universe. So where exactly is this planet located? To understand its position, we must first identify the star it orbits. The planet lies outside our solar system, making it an exoplanet. It belongs to a system located many light years away from Earth. While the exact number of light years depends on the specific planet being referenced, one thing is certain. It is unimaginably far compared to the distances we are used to within our solar system. Light years are a measure of distance, not time. 1 light year equals nearly 9.5 trillion kilometers. That means even if we traveled at the speed of light, it would take us many years to reach this planet. With current technology, sending a spacecraft there would take thousands of years. For now, it remains a place we can only study from afar, using telescopes and advanced instruments. The star this planet orbits is much closer to it than our sun is to Earth. This proximity explains the short orbit of only 18 hours. However, the star itself may differ significantly from our sun. Some stars are smaller and cooler, while others are larger and hotter. Understanding the star is critical because it directly affects the conditions on the planet. Astronomers study the star's temperature, size, and composition to better understand the environment. By analyzing the starlight, scientists can also determine what elements are present. The spectrum of light gives clues about gases in the star and even about the planet's atmosphere. Although we can't see the planet directly, these indirect methods allow us to gather a surprising amount of information. This is how we know that such extreme worlds are real, even without physically visiting them. The location of the planet is not just interesting scientifically, but also philosophically. It reminds us of how vast the universe really is. Even though we know about this planet, the chances of ever reaching it are extremely small. Yet, its existence broadens our perspective of what is possible in the cosmos. It teaches us that our home, Earth, is just one tiny part of an endless variety of worlds. Astronomers often compare such exoplanets to neighbors in our galactic community. While they are not close in human terms, they are relatively close compared to the billions of stars across the Milky Way. Every new exoplanet we discover helps us map the architecture of our galaxy. Slowly, we are building a picture of how diverse planetary systems can be. Interestingly, The location of this planet also provides opportunities for future missions. Even though traveling there directly may be impossible, we can aim new telescopes toward its system. With future technologies, we may one day observe its atmosphere in greater detail, perhaps even detecting chemical signs that hint at how extreme worlds evolve. The sheer distance also highlights the importance of patience in astronomy. Every observation takes time, and confirming the planet's details may require decades of research, but the reward is worth it. Each new piece of data not only explains this planet, but also enriches our knowledge of the universe as a whole. Furthermore, knowing the location of such a unique planet allows astronomers to compare it with others. By studying multiple extreme exoplanets, they can identify patterns and differences. This comparative approach deepens our understanding of planetary science and shows whether the 18-hour year is a rare exception or one of many strange realities. Ultimately, the planet's location reminds us of humanity's current limitations and future potential. Though unreachable now, it may not always be that way. History has shown that today's impossibilities can become tomorrow's achievements. For now, this planet exists as a distant wonder, a reminder that the universe still holds countless secrets waiting to be uncovered. Size and physical characteristics. This extraordinary planet is not only fascinating because of its orbit, but also because of its physical attributes. When astronomers first measured its size, they were stunned to find it much larger than Earth. Some of these ultra-short orbit planets are classified as hot Jupiters, meaning they are gas giants orbiting dangerously close to their stars. Despite their massive size, their proximity to the star causes them to shrink slightly, creating unique density profiles. Understanding these differences helps scientists refine models of planetary evolution. Compared to Earth, the radius of this planet is enormous, and its mass significantly higher. However, its density may actually be lower, especially if it is primarily composed of hydrogen and helium. Unlike rocky planets such as Earth or Mars, this world might lack a solid surface altogether. Standing on it could be impossible, as you would sink deeper into layers of gas. This makes it more like Jupiter or Saturn than like our home planet. The composition of such planets is studied through their interaction with starlight. When starlight passes through or reflects off their atmospheres, certain wavelengths are absorbed. These absorption lines allow astronomers to identify elements like sodium, potassium, or even exotic molecules. For planets this close to their stars, atmospheres can become unstable, evaporating into space over time. This constant bleeding of gases creates tails similar to comets. Its size and mass also influence gravitational strength. Gravity on such a planet would be intense, far stronger than Earth's. If humans could somehow visit, walking would be nearly impossible. The crushing force would weigh down on every step, making life as we know it unimaginable. This highlights how special Earth is, a world balanced between gravity strong enough to hold us, yet weak enough to allow freedom of movement. Another fascinating characteristic is the possible presence of extreme winds. Gas giants with close orbits often develop atmospheric storms, unlike anything in our solar system. Winds could reach thousands of kilometers per hour, carrying heat from the starlit side to the darker side. These storms would be constant, endless, and unimaginably violent compared to Earth's weather systems. Temperature plays another critical role in defining this planet's identity. Being so close to its star, its surface, or what would pass for a surface, reaches thousands of degrees Celsius. Metals could vaporize, and molecules would behave in ways unthinkable on Earth. This hostile environment ensures that no life as we know it could survive. Instead, the planet exists as a natural laboratory for extreme physics. Despite its extreme conditions, the planet may hold rings or moons. If such features exist, they would likely face intense gravitational forces, making them unstable over time. Observing these companions could give further clues about the system's history. For example, moons might have once been larger objects captured by the planet's gravity before being slowly destroyed. Its size also affects its magnetic field. Giant planets often generate powerful magnetic fields due to their internal movements. These fields can trap charged particles, creating massive radiation belts. For a planet orbiting so close to its star, this radiation would be amplified, producing dazzling auroras far more intense than anything seen on Earth or Jupiter. The sheer scale of this planet inspires awe. It reminds us of how varied planets can be, from tiny rocky worlds smaller than Mars to massive giants larger than Jupiter. Each discovery broadens our imagination, challenging the boundaries of what we once thought possible. This diversity proves that the universe rarely repeats itself. Ultimately, the size and physical characteristics of this planet add to its mystery. Enormous yet fragile, powerful yet unstable, it exists in a balance that constantly defies human expectations. Its traits show us that planets are not just places, but dynamic systems, each telling a unique story of cosmic evolution. Extreme conditions. Life on this planet would be impossible for humans. The first reason is temperature. Orbiting so close to its star, the planet's day side likely experiences heat exceeding thousands of degrees. Any material we know on Earth would melt or vaporize instantly. Even the night side, shielded from direct starlight, would still be scorching due to intense atmospheric circulation. Simply put, the entire planet is a furnace. The atmosphere itself adds to the danger. Instead of breathable oxygen, it could contain toxic gases like carbon monoxide, hydrogen sulfide, or vaporized metals. Breathing here would kill instantly. In fact, the atmosphere may be so unstable that it evaporates continuously into space, forming a tail behind the planet as it races through its orbit. This constant loss of gases shows how fragile such worlds are under extreme stellar radiation. Pressure is another deadly factor. If the planet is a gas giant, descending into its layers would mean facing crushing forces. At certain depths, pressures become so intense that hydrogen transforms into metallic hydrogen, a state of matter that does not exist naturally on Earth. Such exotic conditions fascinate scientists, as they provide insights into physics under unimaginable extremes. Weather patterns on this planet would be unlike anything on Earth. Supersonic winds could circle the globe in mere hours, carrying heat from the star-facing side to the opposite side. These winds might also carry metallic vapors, which could condense into droplets of liquid metal on the cooler side. Imagine a rainstorm not of water, but of molten iron or titanium. That's the type of bizarre weather scientists theorize. The constant radiation from the nearby star further complicates survival. Planets this close are bathed in intense streams of charged particles. Any spacecraft approaching would need advanced shielding to survive the bombardment. For humans, unprotected exposure would mean instant death. Radiation levels here make Earth's most dangerous places look safe by comparison. The planet's rapid orbit also contributes to instability. As it races around its star every 18 hours, it experiences constant gravitational stress. This stress could generate internal heating, further fueling its extreme environment. Over time, such conditions may even tear the planet apart, slowly stripping away its mass and leaving behind only remnants. Interestingly, these hostile conditions are exactly what make the planet scientifically valuable. By studying how it survives under such extremes, scientists learn about planetary resilience and destruction. Each measurement teaches us more about the limits of planet formation and endurance. Imagining human life here, even hypothetically, shows the contrast with Earth. On this planet, no crops could grow, no buildings could stand, and no humans could breathe. Every natural law we rely on would be turned against us. That contrast highlights the miracle of Earth's habitability, where conditions align perfectly for life. Some researchers even speculate about whether such worlds could host exotic forms of life. Not life as we know it, but something entirely different, capable of thriving in heat and pressure. While unlikely, the thought excites imaginations, keeping the door of possibility open. Science often advances by questioning the impossible. In the end, the extreme conditions of this planet transform it into a symbol of the universe's creativity. It is violent, hostile, and unwelcoming, yet breathtakingly fascinating. For astronomers, it serves as a reminder that beauty in space is not always gentle. It can also be fierce, destructive, and utterly alien. Orbital speed. The most remarkable feature of this planet is its orbital speed. To complete an orbit in just 18 hours, the planet must move at astonishing velocity around its star. While Earth travels at about 107,000 kilometers per hour, this planet races far faster. Its speed is necessary to counteract the intense gravitational pull of its star. Without such velocity, the planet would be drawn inward and destroyed. The delicate balance between speed and gravity keeps it in place. This rapid motion demonstrates the laws of orbital mechanics in their most extreme form. Johannes Kepler's laws of planetary motion explain that planets closer to their stars move faster in their orbits. This planet is a vivid example of that rule in action. Its extreme closeness forces it into a never-ending sprint, circling its star multiple times within the span of a single Earth week. The orbital speed also affects the planet's environment. Moving so quickly generates tidal forces that stretch and squeeze the planet's interior. This constant gravitational stress may produce internal heating, fueling violent storms and possibly volcanic-like activity. The planet's own motion is part of what makes it so unstable and dangerous. To put this speed into perspective, imagine traveling around Earth in less than an hour. That's how extreme the scale becomes when considering orbital velocity in outer space. Such speeds are almost beyond human comprehension. Yet, for this planet, it is simply the natural rhythm of existence. The universe shows us that what feels impossible on Earth is routine elsewhere. Astronomers calculate this speed by carefully analyzing light curves and orbital data. The repeated dips in starlight allow precise measurement of how often the planet completes its orbit. From that, they derive its velocity. These calculations confirm just how extraordinary this world is. Each pass in front of the star provides another data point, sharpening the picture of its orbital mechanics. The fast orbit also means that the planet is locked in a relentless cycle of heating and gravitational stress. Over long timescales, such stress could destabilize it. Some astronomers believe that planets with ultra-short orbits may eventually spiral into their stars. If so, this world's incredible speed could be part of a countdown to its destruction. Its orbital speed also makes it easier to study compared to slower planets. Because it transits its star so frequently, astronomers can gather data much more quickly. Instead of waiting months or years for a planet to complete an orbit, scientists here only wait hours. This provides repeated opportunities for observation and confirmation. The speed also has implications for its star. Such close, fast-moving planets can influence their stars through gravitational pull, creating tiny wobbles. By studying these wobbles, astronomers learn more about the planet's mass and the dynamics of the system. The interplay between the planet and its star creates a fascinating cosmic dance. For humans, such speed is mind-bending. Imagine living on a world where entire generations could pass in what feels like a week on Earth. The accelerated orbit redefines how we think about time and existence. It makes us question whether life could ever adapt to such an extreme rhythm. Ultimately, the orbital speed of this planet is not just a number, it is a story of survival. Caught in the grip of its star, the planet races endlessly, teetering on the edge between stability and destruction. Its speed is a reminder of the powerful forces shaping the cosmos, forces that continue to astonish and humble us. Scientific implications. The discovery of a planet with such an extreme orbit carries profound implications for science. First, it expands our understanding of planetary systems. Before such findings, astronomers believed planets followed orbits similar to those in our solar system. Now we know the universe creates worlds that defy those expectations. The 18-hour orbit planet forces us to rewrite models of planetary formation and survival. One major implication is the diversity of exoplanets. The more we discover, the clearer it becomes that there is no single template for planetary systems. Some planets orbit 2 stars, others have eccentric elliptical orbits, and some, like this one, complete a year in less than a day. Each discovery broadens the spectrum of possibilities, reminding us that Earth is just one example among billions. This planet also sheds light on the limits of planetary endurance. How can a world survive such intense heat, gravity, and radiation? Studying it helps scientists identify the thresholds beyond which planets cannot exist. This knowledge sharpens our theories about how planets form, evolve, and eventually die. It also reveals the fragile balance required for habitability. The discovery has technological implications too. To detect such planets, astronomers rely on advanced instruments capable of measuring tiny fluctuations in starlight. Each successful detection proves the power of these tools and justifies investment in future telescopes. The more extreme the discovery, the more confidence scientists gain in their methods. Beyond astronomy, the planet sparks philosophical and cultural reflections. If time can move so differently elsewhere, what does that say about our perception of reality? Concepts like years, days, and seasons feel universal, yet they are entirely earthbound. This planet challenges us to expand our definitions and imagine existence under radically different circumstances. For astrobiology, such planets pose both obstacles and opportunities. On one hand, conditions are too extreme for life as we know it. On the other hand, studying these worlds reveals the boundaries of habitability. By defining what is impossible, scientists can better identify where life might actually exist. Extreme worlds teach us what to look for in more Earth-like planets. The implications also extend to the study of stars. The presence of close-orbiting planets affects stellar behavior, including rotation and magnetic activity. By observing these interactions, astronomers gain insight into stellar evolution. Planets are not just passive objects, they actively influence their stars in subtle but measurable ways. In the future, discoveries like this may influence space exploration priorities. While humans may never visit such a hostile world, missions may focus on studying similar systems. Each extreme planet adds to our catalog of cosmic laboratories, where nature experiments with physics in conditions impossible to recreate on Earth. The planet also fuels the imagination of writers, filmmakers, and artists. Extreme exoplanets often inspire science fiction, blending real science with creative speculation. By capturing public interest, they help build support for astronomy and space research. Curiosity is not just a scientific force, it is also a cultural one. In conclusion, the scientific implications of this discovery go far beyond a single planet. It represents a turning point in our understanding of the cosmos. By challenging assumptions and expanding boundaries, it reminds us that the universe is far more diverse, dynamic, and surprising than we ever imagined. Comparisons with Earth. To truly grasp how bizarre this planet is, it helps to compare it with Earth. Here on our home planet, a year lasts 365 days, giving us time to experience 4 distinct seasons, celebrate birthdays once a year, and build civilizations around the rhythm of time. But imagine living on a planet where a year lasts only 18 hours. Birthdays would come multiple times in a single Earth day. Societies would be forced to redefine the very meaning of time itself. If humans tried to live there, the concept of weeks, months, or years would be meaningless. Agriculture would be impossible because seasons would not exist in any recognizable form. Crops that need months to grow would never survive. Any kind of long-term planning would be impossible. Daily life would feel like a blur of rapid change, where the passage of time was too fast to manage. The length of a day versus a year is another striking difference. On Earth, days and years are distinct units of time. But on this planet, a year is shorter than a day. That contradiction forces us to rethink what time even means in cosmic terms. Imagine waking up and realizing that during your sleep, your planet had already completed an entire orbit around its star. Another comparison involves gravity and environment. Earth's moderate distance from the sun allows for stable climates, breathable air, and liquid water. But this planet, with its short orbit, exists in a constant furnace. While Earth is the perfect cradle for life, this other world is more like a natural experiment in destruction. The contrast between the two highlights how rare and precious Earth's conditions truly are. Time also affects biological rhythms. Humans and animals on Earth rely on cycles of light and dark to regulate sleep, reproduction, and growth. On a planet where years last only hours, such cycles would collapse. Life as we know it could not adapt to such relentless acceleration. Evolution itself would be forced down an entirely different path, if life could exist at all. Comparisons with Earth also reveal the importance of stability. Our planet's orbit has remained relatively constant for billions of years, allowing life to flourish. But a planet with an 18-hour year likely faces long-term instability, possibly spiraling into its star over time. Earth shows us what stability can achieve, while this other world demonstrates the consequences of extremes. From a human perspective, such a world would feel alien in every way. Imagine trying to measure history when centuries pass in what would feel like a few Earth days. Cultures and civilizations, if they could exist, would rise and fall in an incomprehensibly short time. It challenges us to consider whether time is simply a construct of perspective. These comparisons also reinforce the uniqueness of Earth. We often take our planet for granted, but the more we study worlds like this, the more we see how rare our conditions are. The habitable zone is not just a scientific term, it is a gift. Without it, life would never have developed as it did here. Earth is not the largest, the hottest, or the most spectacular planet. Yet, in terms of balance, it is extraordinary. The contrast with a planet that completes a year in 18 hours underlines how fragile and lucky our existence truly is. Every breath we take is made possible by cosmic conditions that are anything but common. In the end, comparing Earth to this extreme planet is humbling. It reminds us that our world is not the rule, but the exception. While the universe creates countless bizarre and hostile environments, Earth remains a sanctuary. These comparisons not only highlight the strangeness of the cosmos, but also deepen our appreciation for the rare harmony we call home. Curious conclusion. The story of this planet is one of extremes. A world where a year passes in just 18 hours, orbiting dangerously close to its star, enduring heat and forces beyond imagination. It is not a place where life could thrive, yet it captures our curiosity like few other discoveries. Its very existence forces us to reconsider what is possible in the universe. It reminds us that the cosmos is far stranger and more creative than we ever imagined. By exploring such planets, we learn not just about them, but also about ourselves. Earth feels ordinary until we compare it with worlds like this. Then, suddenly, it becomes clear how special our planet truly is. The stability of our orbit, the balance of our conditions, and the gift of time all make life possible. This alien planet highlights the miracle of Earth. Every discovery like this adds another piece to the cosmic puzzle. Scientists gain knowledge, but humanity gains perspective. The universe is not just a collection of stars and planets. It is a stage of wonders, each more incredible than the last. The 18-hour orbit planet is a reminder that we have only just begun to explore what is out there. The conclusion also opens doors to future mysteries. If a planet can orbit in 18 hours, could there be one with an even shorter year? Could there be planets with bizarre properties we have not even imagined yet? These questions drive exploration, ensuring that curiosity will always lead us forward. For astronomers, this discovery is a triumph of technology and perseverance. For dreamers, it is a story that sparks the imagination. Together, science and wonder combine to remind us why we keep searching. The sky is full of secrets, and each new world we uncover fuels the desire to find more. This planet also leaves us with a sense of humility. The universe is vast, filled with phenomena that dwarf human comprehension. Yet, despite our smallness, we have the tools to detect, study, and understand them. That balance between insignificance and brilliance defines our place in the cosmos. In a way, the planet is both terrifying and beautiful. Terrifying for its extremes, beautiful for its existence. The fact that such a place can exist at all shows the creativity of nature. And while it may remain forever unreachable, it still enriches our understanding of reality. The conclusion also reminds us that science is a journey, not a destination. Each discovery is a stepping stone to the next. The 18-hour-year planet is not the end of a story, but the beginning of countless new ones. What else will we find as our tools grow sharper and our vision reaches further? For now, we can only look from afar, marveling at the extremes of this alien world. But one thing is certain. This planet has already changed the way we think about time, orbits, and the diversity of the cosmos. Its story will continue to inspire scientists and dreamers alike. And so, we close this chapter with curiosity still burning. If one planet can hold such wonders, imagine what countless others may hide. The universe is endless, and its secrets are waiting. Perhaps, somewhere out there, an even stranger world is waiting to be discovered.